I'm at lunch again, so you may hear some bells. I'll try to pause it in time, but if not, I apologize in advance. So today we are looking at section 3.4. Section 3.4 is a huge section, so we did a little bit of it yesterday. And see, I told you I just didn't wait long enough for that bell. And we're going to do some of it today, and depending on how class goes today, tomorrow, we may end up deciding to spend one more day on it. Okay? I'm going to start off by just solving some that have a common base. Okay, so this is solving explanation functions. We're going to start with a common base, but then we'll get to some that do not have a common base. Alright, so first we're going to do a common base. So the general overview is just solving log. So solving exponential and log functions, if you are dying to know what this section is about. Okay, here we go. So number 1, 5 raised to the 3x minus 6 equals 125. So this goes back to what we almost did on when we first started beginning logs, which was if I can get these to the same base, I can drop the bases and just set the exponents equal to each other. So do you agree that I can write 125 as 5 cubed? Now I have the same base, so I can drop them. Drop and solve. So now I can have 3x minus 6 equals 3, and now I just continue to solve the linear equation. So if you can get your bases the same, you're good to go. So now I have 3x equals 9, so x is 3. And let's try one a little more difficult. What if I have 8x plus 2 equals 1/4? So I need to try to get these guys to a same base. So I can think of, what number can I raise to a power to get 8, and what number can I raise to a power and get 4, and I want them to be the same power, and I kind of just slipped and gave you a hint that it was 2. So do you agree that I can write 8 as 2 cubed? Right? 2 cubed is 8. Now, I just can't ignore what's out here, so I'm just going to let it carry. Now, the 1/4 is going to cause you some problems, but let's think back to that section 3.1. Do you agree that 4 is 2 cubed? So, sorry, 2 squared. Let me get my head about me. But because it's in the denominator, what do I write? I write 2 to what? It's the negative 2 power. Now I have the same base, so I can just drop them, and I have 3 times the quantity x plus 2 is equal to negative 2. And now it's solving a straight linear. So if you have any issues with these tomorrow, it's going to be to figure out what that base is. And just ask yourself, what to what power can give me 8, and what to what power can give me 4, and I need them to be the same what. Alright, so you get 3x plus 6 equals negative 2. So 3x is equal to negative 8, so x is negative 8/3. Alright, so that's when we can get a common base. You can't always get a common base. So what happens when you can't get a common base? So what happens when you can't get the same base? So you just can't. And the answer is to divide each side by the natural log. Okay, so if you cannot get the same base, divide each side by the natural log, And I'll explain why that works in just a minute. Okay, so let's look at some problems that are going to require that we can't get a common base. So I have 5 to the x power is equal to 134. There's no way you can write 5 to some power to get 134. You just can't do it. So, first thing I'm going to do is to divide each side by the natural log. Actually, it's change your notes. It should say multiply each side. If you could see what I just did. Alright, multiply each side by a natural log. So, I'm going to take the natural log of 5 to the x equals the natural log of 134. Now, I can do that because as long as I do the same thing to both sides of the equations, I haven't voided any laws of equations. So now I have natural log of 5 to the x power equals natural log of 134. Think about for a minute when you were expanding logs and condensing logs. Do you agree that I can write that as x natural log of 5 is equal to natural log of 134? You're solving for x, correct? So, if I'm not mistaken, I should be able to divide both sides by the natural log of 5 and get that x is equal to the natural log of 134 over the natural log of 5. Now, some people are happy leaving it like this. For some people, that drives them absolutely insane because it doesn't look like a numerical answer. So if you want, you can grab your calculator, and I know there's going to be a glare on mine. Alright, let me see if I can put it down here maybe. So you're going to hit your natural log button, so your ln button, 134. Now notice that it has the parenthesis. Mine, because I have an 84, it wants me to close the parenthesis, divided by the natural log of 5. So if you're looking for a numerical answer, you would put 3 point, and we'll just round to the hundredths place, so we'll put 3.04. But I will accept this answer as well. So for those of you who are okay leaving it in terms of natural logs, some of us like it, some of us don't. I'll take either answer. Okay, let's try one. Again, a little bit harder. I have 3 2x minus 1 equals 7x plus 1. Now, again, you understand why you can't get a common base. There's nothing that you can do to either side to get it. You can't make him get 3 to what power 7? Nothing. 3 to what power 7? Nothing. So you're out of luck. But I can go ahead and multiply this side by a natural log. And the reason we choose natural logs is because your calculator can easily take the natural log of a number. We can get a numerical value. So far I've just taken the natural log. Again, I'm allowed, I did it to both sides. Now what can I do with this exponent? Now bring him out in front. So I have 2x minus 1 times the natural log of 3 equals x plus 1 times the natural log of 7. Now here's where people are going to take two different paths. Okay? Some people right now are going to say, you know what, I am plugging in and getting numbers for those. Others of you guys are going to just say, you know what, I want my answer to be precise. I'm going to deal with those natural logs. So I'm going to show you both options, and then quite honestly, you're going to get to choose what would work best for you. Alright, so option 1 keeps the natural logs. So do you agree that I'm going to distribute this to both those terms? So I have 2x natural log of 3 minus natural log of 3 equals, distribute him, and I have x natural log of 7 plus natural log of 7. Now what I'm going to do is I'm going to just think back to equations. If you had 2x plus 3 equals 5x minus 4, you agree you would move all your x's to one side and all your numbers to the other, right? Okay, we're going to do the same thing here. I'm going to move all my x's to one side, all my numbers to the other. Okay, so I'm going to move this guy over here, and I'm going to move him that direction. Alright, and I will go ahead and do it in 2 steps for you. So first thing I'm going to do is move this guy, because he has an x, over to this side. So, these are gone. I have 2x natural log of 3 minus x natural log of 7 minus the natural log of 3 is equal to the natural log of 7. Okay, I understand. This looks like an absolute mess. So this is for those of you who say, I have to get an exact answer. Alright, I'll explain it a little bit differently in a minute, but just hang in there with me. Alright, let's get this guy moved to the other side. So now I'm going to add the natural log of 3 and add the natural log of 3. So I have 2x natural log of 3 minus x natural log of 7 equals natural log of 3 plus natural log of 7. Okay, so I've at least got my x's to one side, numbers to the other. Now, what do these guys have in common? Oh, they each have an x. So I'm going to go ahead and factor that x out, and I get 2 natural log of 3 minus natural log of 7 equals natural log of 3 plus natural log of 7. And you're almost there. You're one step away. You say, you know what, I need to get x by himself. So do you agree that you could divide by this big mess? Because remember, this represents a number. So I'm going to divide by 2 natural log of 3 minus natural log of 7. What I do to the left side, I do to the right side. These go away, and my final answer would be natural log of 3 plus natural log of 7 over 2 natural log of 3 minus natural log of 7. Now, for some of you, you're like, holy cow, what in the world just happened? Okay? So I'm going to show you a cheating method. Now realize this method may be taken away from you when you guys get to pre-calc, but right now you're learning, so I'm okay teaching you a little bit easier method. Okay? Alright, so I want to go right back here to this red equation, and I want to show you option 2. Alright, so option 2. You know what? Say, I am okay getting an approximate answer, and I'm going to grab my handy-dandy calculator, and I'm going to say, what in the world is the natural log of 3 anyway? And I'm going to convert it to a decimal. So I'm going to call that, now if you're going to do this, let's at least round to the nearest thousandth place. So we're going to call this 1.099. Okay? So I have 2x minus 1 times 1.099 equals x plus 1. Now I'm going to type in natural log of 7. And I get, again, I'm going to go out 4 places, or 3 places, so I'm going to have 1.946. And now I'm going to just solve an equation. So step 1, distribute. So 1.099 times 2, I get 2.198x minus 1.099 equals, and I'm going to distribute over here, 1.946x plus 1.946. Alright, this should look familiar. The decimals are awful, but it's no more than moving the x's over here and the numbers over here. So I'm going to subtract 1.946x. So these are gone. 2.198 minus 1.946 gives me 0.252x minus 1.099 equals 1.946. Alright, again, I understand the decimals are making it kind of nasty, but let's go ahead and bring this over to the other side. So I'm going to add 1.099, 0.252x is equal to, let's see, that's 5, carrier 1, 4, carrier 1, 0, so 3.45, and now I divide by 0.252. So 3.045 divided by 0.252 gives me 12.083. Okay? So you have two answers. Two options, two answers. So if I chose option 1, I ended up with this big creature that doesn't look like a number, but it is. If I do option 2, I get this one. Well, just for fun, let's go ahead and type this big ugly thing into the calculator. And again, I hope you guys can see my calculator. I'm trying to get it so that it doesn't have quite such a significant glare on it. Alright, so, parentheses. Natural log of 3 plus natural log of 7. Close your parenthesis. Okay? So I had the natural log of 3 plus the natural log of 7 in my first parentheses, divided by 2 natural log of 3 minus, oops, let me close that parenthesis, minus natural log 7. Enter. I get approximately 12.114. So that was my answer with numbers. This is my answer, 12.114, if I were to actually keep it in logs. So notice that if you go ahead and do it this way, you are going to get a smidge of a rounding error, but I'm telling you that I'm okay with it right now because this method for some of you is just mind-boggling. Okay? So pick your method, whatever you feel most comfortable with. Alright? And let's see, we are at 18 minutes, and I think at this point I'm going to go ahead and stop here, and I think we'll just practice this tomorrow, and then we'll build from there. Okay? So you guys have a great evening, and I will see you in the morning. Don't forget your practice problems.